This is a 1949 to 1951 Crosley Serenader. It is a cute, really little modern looking kind of Art Deco radio. I love it. I bought it, quite a while ago now for not very much money at all because unfortunately it is missing the white little knob here, which kind of ruins the radio. So it's been sitting in my shop. Looks like I might have at one point fixed up the speaker a little bit, but it's been sitting here and I haven't done anything with it. Also, I needed a 335W4 rectifier, which I now have. So let's take a look at it. Okay, so it's quite ugly underneath. Looks like we have a number of original capacitors. You can see that this one here, don't know how well you can see it, let's see, is split. Let's bring some more light on there. So this one here is split. This looks like it's original. This looks like it's original. This is probably a replacement. There's a little black one in there. The power supply filter capacitor is a Mallory. I don't know if that's a date code of 1948 or not. Could be. 240 microfarads at 150 volts. So we're definitely going to have to replace. I think I'll just. Oh, and look at here. Sometimes you get these sort of early integrated circuits. So here in this little package here, I call it an integrated circuit. I guess that's what it is. You'll have several resistors and capacitors all in one convenient package, which is good for the manufacturer, but very bad if one of those goes back. You have to goes bad rather. You have to sort of figure out what the problem is. All right. Well, I don't know. Should I bother just turning it on? And no, not with that capacitor. So I'll start by replacing that capacitors, or at least tacking one in, and then we'll see what we have. But well, you know what, all of these capacitors are going to have to be replaced, so I might as well go ahead and do that. All right, through the magic of video, let's see what happens. Before we do that work, let's take a look at the schematic and the manual. So there it is with this missing dial and the various color options. Look, this is unusual for that period of time to have so many wonderful colors, but we have the Firebird red, which if you look online, it's probably the most common version of it. And so that's model 11-115U with the white, and your typical All-American 5 tube complement of 35W4 rectifier, a 50C5 power tube, a 12AV6 detector. I can't remember if I tested these tubes or not. I'm sure I did. This one is likely the one that goes bad because it's doing so much work. 12BA6 IF amplifier, and then the 12BE6 converter. So your standard 5-tube radio. There's a nice little picture of it. And unusual, sometimes you see this, but not too often. Sorry about the lighting there. So it will give you the voltages. And you want to test to see whether the voltages are off or on. Really not necessary, which is a simple circuit as this, but if you do run into a problem in your replacement parts list, somehow I doubt I could order those parts right now. And where's the schematic? Oh, we skipped over the schematic. There's your alignment chart, which we'll be doing later on. And alignment procedure described down here, and here's the schematic. So your standard 5-tube layout. Anything unusual about it? Oh, look, there's that integrated circuit. So what does that have inside of it? Trying to read through the viewfinder here. It has some capacitors, some small capacitors. 4 small capacitors. Great. Let's hope those are okay. They usually are of that value. Oh, so here's the power section. rectifier. And it's unusual to see them draw this way, the output transformer so close here. Anyhow, all right, let's take a look, see what we're dealing with. So I'm in the process of changing the capacitors, and let's just test out this power supply filter capacitor just for fun. We're going to be looking for some leakage. I'm expecting it to be, although it does look like it was a replacement. So yeah, so 7.9%. It's showing 57 microfarads, should be 40 microfarads. Let's check the other half of it now. This is a dual capacitor can. There's two capacitors in it. Yeah. Try that again. 8.3%. So those are going to have to come out of there. Just for comparison's sake, that's the original dual can, and that's what we're replacing it with, these two 47 microfarad 150 volt capacitors. Out with the old and in with the new. So I mean, I'm just an amateur hobbyist here, so it wouldn't be appropriate for me to criticize other people who work on radios, but whoever replaced this capacitor and this supply filter capacitor sure like to use a lot of solder, because there were huge globs of solder attaching these things. So half the time I spent working on this was removing that solder. So anyhow, we have the new capacitors in there, and I like to use this white, it's called spaghetti wire, and use it to cover the leads here to avoid any shorts. And we've replaced the supply filter capacitors with these smaller but equal valued capacitors, and I think we're just about ready to try it out. Well, we'll see what happens. So as always, we're following safety procedures here. We have the radio plugged into a current limiter, which is plugged into a variac, which is most importantly plugged into an isolation transformer. And the isolation transformer does not eliminate, but reduces the likelihood of a shock. The current limiter reduces the likelihood of a surge of current if there's a short in the radio. So anyhow, we'll bring up the voltage slowly on the variac. We're up to 60 volts now. And usually I find that these radios kind of kick in at around 90 volts. But I'm just going to watch for magic smoke. Again, I can't recall whether I tested these tubes or not, so we might end up having to replace the tubes. And we're coming up on 90 volts there now, so I'm just going to leave that for a second and we'll see whether the tubes heat up. Looks like the heaters, at least on the 35W4. Oh, there we go. Getting some noise. Oh man, this is very stiff. Should have checked that first. Capacitors. Lots of noise here. Let's see if we can pick something up. There we go. Yeah, well, at least we got some noise out of it. We're going to have to do an alignment and clean it up a little bit. See what the sound is like after that. So we are set up for an alignment. I have my signal generator set to 455 kilohertz, which is the intermediate frequency. And it's a modulated signal at, I think, 1,000 hertz or 1 kilohertz. And I have my multimeter attached to the output, and set to AC. So we're measuring the signal that's being generated, and we're trying to peak that signal by adjusting these IF transformers, or these intermediate frequency transformers. So we're trying to get these to resonate at 455 kilohertz, and there's a primary and a secondary. We're going to start with this one here and adjust it. I'm not going to take you through the whole process because it's the sound is very annoying, as you can tell, but we'll see whether we can. I'm using a plastic screwdriver to reduce the interference, if you like. That's decreasing it, so that's not very good. We're going to turn it this way. And so on. And then I'll adjust the other side. And at the end, we'll have both IF transformers adjusted. Then we'll adjust the antenna and the oscillator coil, and away we go. Well, it's all together again without the knob, of course. It doesn't sound great. It's a little bit of distortion. That could be the speaker. Reception's not bad. I've done the alignment, and I think maybe I might replace that speaker. Anyhow, we'll come back to this. Cool looking radio.